Problems based on the integrated rate equation. First question is, a reaction is 50% complete in 2 hours and 75% complete in 4 hours. The order of the reaction is, for the given data, we can write that T 75% is equal to twice of the time for the 50% completion, because 75% take the time 4 hours, while the time to complete 50% is the 2 hours. And this equation is applicable for first order reaction, which we have already derived. Therefore, option A is the correct option. Second question is, when initial concentration of reactant is doubled, the half-life period of the zero order reaction is. For zero order reaction, half-life is defined as initial concentration divided by 2 into rate constant. If R0, which is the initial concentration, is doubled, then new half-life will be equal to 2 into R0 by 2k, and this will be equal to the twice of the initial half-life. So half-life is doubled. Option B is the correct option. Third question is, in a first order reaction A to B, if K is rate constant and initial concentration of the reactant A is 0.5 m, the half-life is, we know that for first order reaction, the half-life is independent of the initial concentration of the reactant, and half-life is given by log with base E divided by K, hence option C is the correct option. Fourth question is, half-life period of a first order reaction is 1386 seconds. The specific rate constant of the reaction is. Formula for specific rate constant is 0.693 divided by half-life, and it is equal to 0.693 divided by 1386. Solving it, it is 693 by 1386 into 10 raised to power minus 3, and on dividing it will come 2, so it is equal to 0.5 into 10 to the power minus 3 per second. Hence option B is the correct option. Fifth question is, if 60% of a first order reaction was completed in 60 minutes and 50% of same reaction would be completed in approximately, where log 4 and 5 value are given. For first order reaction, we know that rate constant K is equal to 2.303 by time taken in completing the concentration from A is the initial concentration, to A minus X. This is the final concentration. So we have 2.303 divided by time is given 60 minutes for the concentration to be completed by 60%, that is A minus 0.6 A. It will be equal to 2.303 by 60 log, and it remains 1 by, on solving it will become 0.4, or 2.303 by 60 log 10 by 4. We can write it as 2.303 by 60 log 10 minus log 4. Log 10 is 1 if base is 10, and log 4 value is given, it is 0.60. So we will have 2.303 by 60 into 1 minus 0.60. So it is equal to 2.303 by 60 into 0.4, and on solving we will have it is 0.0153 per minute. Now time is required to calculate for 50% of the same reaction to be completed. That means we require half-life in which the concentration of the reactant get completed or used by 50%. So it is 0.693 by rate constant. Rate constant we have already calculated above. It is 0.0153. So on solving we will have 45.31 minute as the half-life. Hence option A is the correct option. Sixth question is, if the rate constant for a first order reaction is K, the time required for the completion of 99% of the reaction is given by. For first order reaction, we know that rate constant K equal to 2.303 by T log initial concentration A by initial concentration minus the concentration exhausted, that is X. As per the given data, 2.303 and time is T log. Initial concentration is A and the completion is 99%. So it is 0.99 of the initial concentration. Therefore, we will have 2.303 by T log A by 0.01 A. A and A get cancelled. So it is 2.303 by T log 100. We can write it as log 10 square, and it is 2.303 T into 2 into log 10, and this is with base 10, so this value is 1. Therefore, K will be equal to 4.606 by T, or T equal to 4.606 by K. Hence, option D is the correct option. Next question is, the rate of first order reaction is 0.04 mole per liter per second at 10 seconds and 0.03 mole per liter per second at 20 seconds after the initiation of the reaction. The half-life of the reaction is, because the reaction is first order reaction, so rate constant is 2.303 by T2 minus T1 into log concentration at time T1 divided by concentration at time T2. So it is equal to 2.303 divided by T2 is 20 second minus and T1 is 10 second log, and concentration we have to convert in terms of the rate, because for first order reaction rate R is equal to rate constant multiplied by the concentration of the reactant. That means rate is proportional to the concentration. Therefore, we can write the concentration R1 in terms of rate R1 for the time T1 and rate R2 at time T2. Therefore, it is 2.303 by 10 log, and rate of reaction at time T1 is 0.04 divided by, and at time T2 it is 0.03. So it will come 2.303 by 10 log 4 by 3. We can write it is 2.303 by 10 log 4 minus log 3. This is 2.303 by 10. Log 4 is 2 log 2 minus log 3, and we can write it is 2.303 by 10 2 into log 2 has the value 0.3010 and log 3 has the value 0.4771. So we substitute this value, and on solving the rate constant will come 0.0287 per second. Now we have to find the half-life. So half-life will be equal to, for first order reaction, 0.693 by rate constant. So it is equal to 0.0693 by 0.0287, and it will be equal to 24.14 seconds. Hence, option C is the correct option.